I'd like to walk through very quickly a post-op Lasik review on the Insight 100 software. Here we're doing a quick review of the Lasik flap. Simply select the patient, double-click on the image capture. I'll walk through a couple of the options. We've taken multiple meridian scans of the cornea, 0, 45, here's a vertical scan, and here's the 135 scan. So there's each of them here. This represents nearly 10 millimeters of cornea exposure. The reason why this is not a perfectly curve that you're used to seeing is the patient leaning in and out, maybe even taking a breath. This is microns of movement. The ultrasound is keeping up with it so that you have consistency of the measurements throughout. I can go ahead and turn on an A-scan right here. Now this is anterior segment A-scan alone. We're a high frequency ultrasound, so we cannot detect the full axial length of the eye. Wherever my cursor is, here is the epithelium layer. This is Bowman's membrane. And this is the flap. This could be a smile flap, it could be a smile pocket, or it could be a Lasik flap. In this case, I happen to know that this is a 10-year-old Lasik patient, so we're still able to image this well. The back surface is the back surface of the cornea. This is not the endothelial cells. They're just simply too thin to measure. This is simply the barrier between tissue and aqueous humor. If I were to double-click with the cursor here, we get a green arrow. Now I can walk over and I can talk to you here. The flap is 144 microns from the epithelium to the flap or pocket. The epithelium thickness at this point is 54 microns thick. So if I wanted to know what the tissue thickness was between Bowman's membrane and the flap, I would simply subtract 54 from the 144, 90 microns, which is really close to that safety zone if you wanted to do a thin flap Lasik. Double-clicking again releases, and I'm able to move around. In order to retrieve the existing epithelium maps, or the keratoconus report that's built into our system, the operators need to look at each of the individual images, scans that were taken, and verify that indeed that our pickups were accurate. In this case, we can see that all of them picked up just perfectly. I simply click Reviewed, click to the next image. Same thing, we're taking a look through here to make sure that they've all been caught up, they're looking good, hit Reviewed. Next image. Here you can see the flap is back here, but the ultrasound didn't quite pick up the flap in those areas. So there's some tools across the top. Right here is an automatic pickup. So if I click on that, bring my mouse back over here, I'm on the left mouse button, I click, hold it down, and now I can correct exactly where that flap is. You want to take your time doing this, because this work will indeed affect the outcomes. If you're having a difficult time seeing the flap, right mouse, hold down, change brightness, contrast, etc., to really emphasize that anatomical structure, in this case, the flap. Mouse wheel, I can zoom in, hold the mouse wheel down, I can pan. Back to that. Now let's finish our work. Simply draw down, all the way down. Yes, this takes a little bit of practice. Practice makes perfect. You want those perfect outcomes. This is the effort that we have to go through. Up at the top, I can see a little pickup up here. There's nothing there. Eraser tool, click. Left mouse, hold it down, erase those. We're good to go. Back off. I've done a good review of that. I can hit Reviewed. Again, you have to go through each and every one of them, make sure your corrections are done. As a points of interest on this image, here you can see the entrance point of the keratome breaking Bowman's membrane. Post-operatively, important to note, how did they line up? Does Bowman's membrane line up nicely? Are there any macro folds in here, etc.? So again, I can bring that down, a great image. Click on Reviewed. Now that all 4 of these have been reviewed, our maps are now available. Here are the epithelium maps. There's options here as well. As I move my cursor over the epithelium map, that is the actual thickness of the epithelium wherever my mouse cursor is. If you don't like the rectangular grid pattern, down on the left, we can go to a circular pattern. Here you can now see the actual optical zone of what we're capturing. So from the center, there's the 1 millimeter ring, so that's 2 millimeters across, 4, 6, 8, 10 millimeters. So in this case, we certainly caught at least 8 millimeters of optical zone of the epithelium. This is the stroma base. So this is stroma back to the back surface of the cornea. Again, there's your thickness maps, etc. If you are concerned about whether or not you captured all the data, you can also click on the meridians. So here's the meridians overlaid, and in this case, those meridians aren't all lined up exactly. The patient did not maintain a fixed gaze, looking straight ahead. However, we do make corrections within the software to pick that up as best as we can. We always instruct the operators to tell the patient, keep looking straight forward, just like underneath the microscope, gazing forward at the target, gazing forward at the target. Each of these scans is less than a half a second. We want to make sure the lids are out of the way. In this case down here, we had a little bit of lid in the way. That's why there's no data on this screen. The other important component here is a keratoconus evaluation. Now this is a post-op patient, so it's a little bit different. Nonetheless, here we have the epithelium map, stromal base, and entire cornea. This is a tomographer, not a topographer. Therefore, we have a little bit different color gradation, color scale. This here is a standard deviation map. From a patient population of approximately 7,000 patients, we have a lot of data on what a normal cornea would look like. And in this case, as I move the mouse around and the colors equate to the scale over here, we are, in this case, where my mouse is, about 2.5 standard deviations thicker than a normal cornea or a normal epithelium. And the same with the stromal base here. On the right-hand side over here, comprising of 140 patients or so, we have a keratoconus classifier. The RSK is not risk. A lot of people tend to say that, but it's Reinstein-Silverman keratoconus score. In this case, this is not a keratoconus patient. It's well above the line. These are the 4 gradations of keratoconus patients. If this line were down here in a pre-op, you would make the determination if they're a keratoconus patient. Instead of doing Lasik, you're probably going to do an ICL or maybe even a PRK on that patient. So this is a quick walkthrough. Again, if you wanted to go back and take a look at anything that you're looking at here, like why is this a little bit thinner over here, you can go back to the analysis and see the various maps. Use your ArcScan and walk up and down to see exactly what that is. Now, I mentioned how this is not your typical looking OCT type image. Well, if you want to look at the corrected view, here we have what would normally be, you might see in an OCT. Again, brightness, contrast. An OCT is going to have a very difficult time picking up the Lasik flap there, unless it's directly after surgery. We also have a multi-frame view. You can look at the multiple frames that you've taken, and you have all of that available in reporting. So you can save and or print these reports right to your local hard drive, export them into your PAC system for your EMR records, etc. So that again is a quick review of the keratoconus for a post-op Lasik SMILE patient, determinations as to health of your procedure. Thank you very much.